Hello, and welcome to the MEGIN Spotlights, the podcast where we shine a light on the people and organizations pushing the boundaries of neuroscience and brain health. I'm your host, Nicole Bruff, and today we're diving into the world of consumer brain health with a company that's making huge waves, MYndspan. We're especially excited about this conversation because MYndspan is also a strategic partner of MEGIN, working with us to advance MEG technology and bring it to a wider audience. Joining me are MYndspan's co-founder and CEO, Caitlin Baltzer, and Chief Scientific Officer, Dr. Benjamin Dunkley. Together, they're pioneering new ways to use non-invasive brain scanning to better understand brain health. Caitlin, Dr. Dunkley, welcome to the show. It's great to have you here. So let's start at the beginning. Why do you think consumer health data is becoming so important, and how did MYndspan first come about?
Yeah, effectively, I think it's becoming so important for two reasons. We're living longer and we want to be healthier while we're living longer. And so you see this proliferation in wearables technology, tons of consumer data. People want objective measurements that are actionable when it comes to their healthcare. They don't want to rely on a healthcare system to keep them healthy. And so it's becoming more and more important. And you see this also in the proliferation of these whole body preventative health assessments. And so when you look at those types of services, you see that like rarely do they do a cognitive assessment, which is measuring kind of the output of your brain. And if they do look at the brain, it's usually an MRI. So it's structural, it's looking at maybe atrophy in the brain. And as your audience would know, we know that function changes far before you have changes in symptoms. And so, really, we wanted to focus on that. And really, the founding insight is that we believe that MEG is one of the most information rich and underutilized tools in neuroscience. And so MindSpan was created really to unlock that potential by making MEG more accessible, more scalable, and really importantly, more interpretable. Because we see that there's a really big demand for this type of information. So we leverage the fact that not only is it an incredible data source, but really it's completely non-invasive. It's an incredibly easy and quick experience, unlike some modalities like MRI, which can be a little bit claustrophobic or loud. And so it really lends itself to a service like ours. What do you think, Ben?
Yeah, Ken is exactly right. We do provide these scans and analyses for consumers who want this information about their brain health, about their brain function. But we're not just a scan provider. We're really trying to build a standardized operating layer around data acquisition, both MEG and cognitive data, a standardized analyses of that data, and interpretation of both the MEG, cognitive, and accompanying data that we capture during a scan. Again, this is really leveraging the fact that MEG benefits, from exceptional replicability and the stability of the data. We now know that even over sort of 3 years and more, brain function is very, very stable. Individuals have quite stable brain data even over 20-second periods. We know that generate very replicable, well-validated data sets. This brain fingerprint we can get out and we can image with MEG very well. And we want to show that, these measures are replicable and stable across different types of analyses, across different sites, and from different technical and technician acquisition protocols. So we really aim to bridge the gap between cutting edge MEG and real world clinical, consumer, and translational applications, and expand the ecosystem of MEG, out into the real world, sort of beyond research and clinical use, and not just build a standalone scan company.
It's really interesting. So, could you both walk us through what happens during a MindSpan scan? What kind of insights can people expect to learn about their brain?
Yeah, happy to. I can walk you through kind of the experience from a consumer perspective, and then I'll hand over to Ben to talk about the reports and the measures that go into them. But effectively, anyone is able to make an appointment on our website now. We have a handful of partner scanning sites that we use. And so an individual would come in, it's about a 45-minute appointment with us. The first 20 minutes of that appointment is on an iPad app. Here we collect a bunch of metadata, age, biological sex, past diagnoses, any medication an individual might be on, so we understand what is changing or affecting that brain activity. And then we do some gamified cognitive tasks, things that measure short-term working memory, visuospatial skills, that kind of thing, in addition to a bunch of lifestyle data. So we also collect what we call the 3 pillars of brain health, because these are tend to be the levers that everyone has access to change their kind of brain and mental health, and that is nutrition, sleep, and exercise. And then after that iPad process, they go for a 10-minute resting state MEG scan. So as your audience will know, it's completely non-invasive, it's silent, it's resting states, there's no task, and an individual is tasked mostly just with not falling asleep in that scanner. And then once they leave, that information is uploaded to our platform where it's combined with the cognitive assessments and the metadata. And one of our team members effectively ensures that the data quality is good, that it is true physiological data in that assessment, and then it is emailed out to our clients. And yeah, under a 24-hour period. But I can have Ben walk you through kind of the measures that's also in those reports for consumers.
Thank you, Caitlin. Yeah, so just touching on a few of the measures that we pull out and report. One of the main ones is the estimated brain age of an individual. So we really compare their chronological age against the estimates of where their brain function is across the lifespan. So using what we call a normative model approach, we have a large neurotypical data set across the lifespan. And from that, we've pulled out a set of features which we know change quite linearly as we age. And we can look at those features and we can compare them in an individual's data set and basically predict what an individual's brain's functional age is relative to their chronological age. So what does that tell us? It tells us their brain age gap. So it might show that an individual's brain maturation is different from the trajectory we might expect. So you can pick up accelerated brain aging, potentially from injury or disease states. So you might see changes in brain age relative to, say, some sort of intervention. Let's say someone goes through some sort of therapy or is trying to implement a new diet and exercise regime. You might see changes in their brain health come more in line with their chronological age. So that's a really kind of intuitive and validated measure that we report straight up on our client report. We've got others in there as well. Another one is peak alpha frequency. This is a measure that's been around for many years. It was actually measured over 100 years ago in EEG and tells us a little bit about the integrity of specific brain circuits. So everyone has like a dominant brain rhythm. Generally, it's around about 10 hertz, but it can vary naturally between about 8 to 12 hertz. And what it tells us is how well the thalamus and the cortex is connected and how they're firing and synchronizing together. But it's got a lot of useful information in there. It correlates very highly with cognitive measures. It's a potential reliable index of neurodegenerative disease states. What we see is that in people with, say, dementias or other types of neurodegenerative issues, that peak frequency will change and get slower as we age. And if it's abnormally slowing, that's a pretty good indicator that there's some sort of disease process ongoing. So it's got clinical and other health implications as well. And more broadly, we compare each individual's data set to a large normative data bank, so we can quickly identify statistical abnormalities in their brain function. So while it's not diagnostic or clinical in a sense, we can absolutely pick up functional brain abnormalities. And we know some of these markers are directly related to, say, brain injury, again, neurodegeneration, some psychiatric disorders and things like that. And these are based on both changes in local activity in different brain regions that we know have different functions and processes, as well as how different networks coordinate and communicate with one another, which is, very important in all sorts of disorders of the brain. So we pull out a number of measures and those are all reported on our client report.
And so before the scan even happens, how important is the information people share with you? For example, any medications, lifestyle data, or even integrating future wearable data like sleep tracking?
Yeah, super important. Like I said before, I think one of the things that we collect even is if you've had caffeine before the scan, because we know, and medications, we know that there are certain medications that have a very identifiable signature in the brain. So we don't think MEG data, neural data on its own is really all that informative. What makes it really informative is the context within which that brain is firing and that neural data is analyzed. So that's part of the reason why we collect all these measures and part of our questionnaire process. But I can pass over to Ben, who can be more scientific with that.
Thank you, Caitlin. Yeah, MEG data is incredibly rich and complex and tells us so much about the brain, but really without context, it can be much more important and much more valuable with that contextual information, information about clinical history, about potentially diagnosed disease states, how you're feeling on the day of the scan, your age, sex, your cognitive function, all of those things. So this is why we collect information on sleep processes, diet, body composition, because it all gives us a contextual picture. And this is really feeding into this idea of like big data and multivariate analytics, in future looking at associations between many different variables rather than just saying, okay, do you have this brain disorder or not? And are these kind of markers in line with what we would expect? But really, these very complex associations between all these different variables. So it provides context, it improves the interpretation of the data and the long-term research utility and the insights of the data. From a research context, it really helps us begin to sort of stratify subgroups. Say you're looking at different disorders of the brain, say concussion. That's where I've done a lot of research, and there are different subtypes of concussion. There's like the emotional subtype, the cognitive subtype, and collecting this wealth of data allows us to then say, okay, how do particular brain markers map onto those different subgroups? It explains inter-subject variance and things like that, and it really strengthens the value of the longitudinal data and the multimodal analysis and the direction we're heading with regards to multivariate analytical approaches.
So, who's currently using MYndspan, and what does your client demographic look like right now? Could you share a client case where your service has made a difference?
Yeah, for sure. I can give you a bit of an overview of the type of client we typically have and then hand over to Ben to talk about some case studies as well. But we typically say we generally have one of two profiles of individuals who come to us. It's either those who are at risk, typically, as Ben mentioned before, as a consequence of his focus area, we scan a lot of athletes at risk of concussion. Individuals who are aware of that risk and want to come in and kind of monitor the kind of either cumulative effect of those subconcussive hits or really along a recovery pathway. And so that kind of at-risk group who are just really conscious and proactive about their brain health. And then the other group is what we call the worried well. So individuals like myself who are really just, I wear an Oura ring, I track my sleep and my other healthcare data. I also, because effectively I have a family history of dementia and neurodegeneration, so it's something that I want to track and monitor and really be proactive about. So it's really kind of those two profiles of consumers who we find are coming in for scans or on our wait list. We currently have a wait list of over 2,300 individuals who want access to this information and want to kind of put this into a preventative healthcare practice for themselves. But that being said, not just consumers who are the ones who want access to kind of scans and the data. We also partner with researchers and clinical partners and kind of other groups interested in more scalable kind of MEG analysis and interpretation. But yeah, I can hand over to Ben to talk about some case studies because we've definitely had quite a few informative and interesting ones.
Yeah, so one of the case studies that I really would like to talk about is an individual with a long and distinguished career in the military, many deployments, lots and lots of incidents of neurotrauma, both from sort of explosions as well as some concussion type events. And they were medically discharged from the military because of the persistent neurocognitive issues they were experiencing. And their MRI was effectively normal. There was a little bit of sulcal widening, but they were deemed to have probable CTE, chronic traumatic encephalopathy, which is a dementia type disease, proteinopathic disease, where there's long-term chronic neurodegeneration that can express, over many years. It's very common in contact sports, rugby, football, hockey, that kind of thing. But they were medically discharged. They were otherwise, trying to fight their case with Veterans Affairs. And they came in for a couple of MEG scans. And the MEG scans showed really pronounced, very abnormal slowing of the brain. So this delta wave activity, we call it. And this is really transient periods of when the brain's just turning itself off. Like it's cortically silent. There's not much processing going on. And it's been implicated, in very serious, moderate, severe TBI cases, neurodegeneration. And what we found was that this abnormal low frequency activity in the brain localized to the frontal and posterior pole. And there was a paper from a few years ago that showed that this is the exact regions where tauopathy was occurring in US military veterans with probable CTE. So, the MEG, of course, this is a single data point, but really showed that was able to localize this sort of hidden information, this invisible injury in this individual. And they expressed, an amount of relief at knowing this information. And we actually got them to come back about 4 months later, and we saw an identical signature. It was exactly the same place, the same magnitude, and was really in line with what we know about their symptoms, what we know about proteinopathic burden in the brain and CT more broadly. So this was a case where we were able to identify these brain abnormalities using the MYndspan process. So that's one particular case study. We're hoping that comes out as a NATO paper in the near future. That's been accepted for publication. And in terms of more client-facing consumer case studies, we had one particular case where an individual was shown to have a predicted brain age close to their chronological age. They had multiple longitudinal scans, and then one particular event when they came in for a scan was very stressful. They were jet lagged. They found that their car was towed when they were trying to make the appointment. They were late for their appointment. It was a heady wind of stressful events, environmental stressors. And with the MEG scan, we found that their brain age gap was significantly increased. And there were these other markers of sort of like transient acute stress in the brain that we saw. And then when we scanned them again, eventually, once they returned back to their usual lifestyle of exercise and diet and nutrition, that their brain age became more in line back with their chronological age. And some of those acute sort of stress type markers in the brain had disappeared effectively. So, those are just two case series of really the applied use of MYndspan's analytics.
And just to give a bit of extra color on that as well, is that it's really easy if you don't have objective data to fall into a stressful lifestyle, and because you don't have objective measures of your brain and mental health, to not really realize the impact that has. And so really what's incredibly powerful is you compared to yourself, and that you can this individual knows what is kind of their norm and what trajectory they're on, and then can actually just objectively see the change, and then therefore it is actionable information that they can go and really kind of get back into a routine, go into the gym, decrease alcohol consumption. There's a handful of other kind of lifestyle interventions that took place there that really saw kind of the measures come back down. So I think that is incredibly powerful, because left alone for 10, 15 years of a stressful lifestyle with no kind of routine, left unchecked, those things compound, and then you start to have symptoms. But when you have symptoms, we know that those changes should have been made 10 years ago. And so that's really where we're trying to focus our attention, is really getting this information into people's hands that can make these lifestyle changes, for themselves.
Thank you, Kate.
Well, thank you for sharing the case studies. I think that's always helpful for our audience to hear as well. So, changing directions a little bit, you've also been building a unique data set. Can you tell us more about how that's being used and how it could support future MEG research studies?
That's a great question, Nicole. Yeah, one of the major bottlenecks in translating MEG, to new markets and new uses and new applications is not just the scarcity of data, but having well-structured, comparable, scalable, validated data sets. So we really want to deliver our clients a meaningful and useful data. So we're focused on curating anonymized data, and building this neurotypical data set, which would provide a comparative reference framework, or a normative model, as we would call it in neurosciences, for individuals, enabling external validation with other data sets. We've been looking at other open source data sets and how ours compares, and making sure our markers are well validated, helping test biomarkers or analysis approaches. We've kind of adopted a standardized analysis approach, which many labs in the neuroscience community use. So, we're well validated. We align with a lot of the scientific data out there. We've been testing biomarkers. I mentioned some earlier on that, have been around for a long time, and that are reliable, repeatable, and well validated, but also supporting multi-center translational work, working with other MEG labs, clinical sites, be it hospitals or research centers, universities. I'm starting to translate that work. There's been some absolutely amazing MEG studies and findings over the years, but really starting to actually apply this in the real world in both sort of clinical and healthcare settings, and individuals' brain health more broadly. So, as part of our mission, we're helping enabling all of those facets.
Can you highlight any new research from MYndspan?
I'll let
Yes,
Ben take this one because he's been busy.
Thank you, Caitlin. Thank you, Nicole. So really, in terms of demonstrating utility, we just had a paper accepted that will be out very soon in MBJ Parkinson's disease, where we used an open source MEG data set from the Quebec Parkinson's Network. And we showed that applying our AI/ML modeling really provides very good discriminative accuracy in detecting Parkinson's disease. So, this is kind of part of our overall mission of using large open source curated data sets from MEG and combining it with our analytical approaches to start to show sort of clinical value. More generally, from other data sets, we've been looking at the interaction between sleep and cognition. We know sleep is such an important pillar of brain health, right? Poor sleep is associated with all sorts of issues, psychiatric, neurological, but primarily in our day-to-day cognition. If you have poor sleep, you feel fatigued, your working memory is shot, your mental flexibility, your attentional abilities. So we looked at how sleep and cognition were intertwined and how it mapped onto brain function, and some really beautiful data from the CAMCAN data set there. So we currently have a preprint out looking at that. And what we found was that those individuals who report poorer sleep reported poorer cognition, so that makes sense. And then this latent variable mapped onto brain function. What we actually found was that those individuals reporting poorer sleep and poorer cognition had slower brain activity and disconnected brain networks. So really starting to show that, even in non-clinical, non-pathological cases, there's this really intricate correlation, interaction, association between brain function, brain health, and cognitive and sleep as well. So that's just a couple of cases of our most recent studies, and our longer term plans are to validate some of our longitudinal measures, like the Brain Stability Index, which just shows how stable and how repeatable your brain function is over time. So it's great for picking up changes relative to your baseline scan. So that paper is currently in preparation.
So what's next for MYndspan?
A lot. Yeah. We've been busy, and I know I sound like a broken record at times, but our focus is really accessibility and scalability. So we are working on expanding kind of the accessibility of our sites, whether that be bringing new partner sites on board or our own scanning sites. So we're really focused on that. And then we also have now just launched the ability on our website. So anyone who might have a MEG data set, they can upload that to our website. We can process that and kind of provide the output of our pipeline. Because we recognize that not everyone has access to come to the UK or Canada to get one of our scans. So we really want to make sure that people with just the data would also be able to get some of our assessments. So we're excited about that. And and new partnerships that we hope to announce soon as well.
Thank you, Caitlin. Yeah, if I could just jump in. So we've been going through a number of partnerships and collaborations with research centers, some amazing research teams. Like research and development, R&D is really at the center of what we're doing, developing these markers, validating these markers. And as I said, we've got a number of ongoing academic collaborations, and we really want to expand the utility of MEG and its data. So we're always open to collaboration, research partnerships. So if there's any researchers out there interested in working with us, please reach out.
Fantastic. So, Caitlin and Dr. Dunkley, thank you so much for joining us today. It's been an incredible look behind the scenes of MYndspan's groundbreaking work and the future of how we understand and protect our brains. Thank you both for joining us.
So much, Nicole.
Thank you.